We obviously just went through a very clear-cut example in which the experimental design allowed us to make a causal statement when we were comparing the two groups, right? Unfortunately, this is not always going to be the case, right? We may be given some data and we need to know whether or not these two variables are dependent on each other, right? There's a co-association, and if we make any inferences from that, we may be biased because there may be some lurking endogenous variable that can explain that relationship. So the first thing we want to do is think about just generally how can we display this data more informatively in order to show the dependencies that exist within it. We're going to talk about how to conduct a chi-square test of independence, and within that, we want to know exactly where the variations are occurring, and we're going to do that through the construction of standardized residuals. To begin, let's just think of an example where we may be comparing two different groups and we have two different categorical variables that we want to measure the relationship between. Now, we, again, may have three different samples, so our data may look like this, where our variable 2, our explanatory variable, is 0, 1, 2, and we may have some outcome response. We'll just say there are 5 different categories, so 1, 2, 3, 4, 5. The key here is that we want to assume that these two variables are nominal. Now, remember, these could be variables like party ID or race or ethnicity. There's no ordinal structure to the data itself, right? Democrats aren't higher than Republicans, they're just different categories. It's important to remember this because the calculations are going to be very different if these are ordinal variables, and especially if both of them are ordinal variables. So if you're interested in that, take a look at the end of chapter 8 in A&F. Now, assuming that we have nominal variables, we're going to use a contingency table. Now, you may hear some people talk about cross tabulations. I usually refer to it this way, but I've heard people use contingency table, and that's how it's referred in the text. So I'm going to keep saying it in that manner. But we can think of an example. Maybe this is individuals' preferences over abortion, and we're getting this information from some sort of survey where the question is asking individuals, please tell me whether or not you think it should be possible for a pregnant woman to obtain a legal abortion if the family has a very low income and can't afford any more children. The information that we have is how they responded to that question, yes or no, and we have information on their partisan preference. So whether they're a Democrat, Independent, Republican, or other. And here you can see we have the contingency table or cross tabulation of the Democrats that said yes and no, Independents yes and no, and so forth. Another way that might be informative to view the data is to look at just a simple histogram where we break down the outcome based on partisanship. But again, the important thing to remember is that this is not an experiment, right? Being a Democrat is probably going to inform your preferences, or rather, sorry, your preferences with regard to politics, like preferring to be a Democrat, is also going to influence the likelihood that you're going to support an abortion policy, right? So we need to think about what do we do in this context? What we really want is some sort of conditional distribution of the outcome, right? Given the likelihood that I am a Democrat, what is the likelihood that I support an abortion policy? So how do we get that? We need a distribution of the outcome variable that's conditioned, right, on being part of that grouping. So let's break it down into proportions first. So in this table, we have the proportions based on the rows, right? Based on within the grouping, how many Democrats said yes and how many said no. So this is important because the rows are going to be our independent variables. Now, if we wanted to have our columns add up to 100, then it would have to be the case that that's going to be our explanatory variable. And that's just mechanical, which we'll talk about in a couple of slides.